Whether we are there or not, ITSP Magazine still gets the best stories. Plenty of conferences and events spark our curiosity and allow us to start conversations with some of the world's brightest minds. In person or virtually, Sean Martin and Marco Ciappelli go on location and sit down with them at the intersection of technology, cybersecurity, and society. Together, we discover what the synergy of these three elements means for the future of humanity.
And hello, everybody. You're very welcome to a new episode of On Location here with Sean and Marco. And you might be wondering where Marco is. He's not here for a couple of reasons. One, I love AppSec. Marco, not so much. And two, this is a technical conversation, and he tends to leave me to do those as well. So here I am flying solo. We're covering the OWASP AppSec Global event in Lisbon, which is in a couple of weeks. And I picked a few topics that caught my attention, and some speakers that caught my attention. And Soheil is one of those. Soheil, thanks for joining me.
So hey everyone, thank you so much for having me, and thank you, Sin, for having this chat with me. So it's great to be here with you. So maybe let me introduce myself, the background about me. So I'm Soheil. I'm a security researcher at CISPA, Center for Information Security here in Saarland, Germany, where I've been working for the past couple of years, doing my PhD here. So my research interests lie in the intersection of web security and privacy, particularly vulnerability detection, larger scale internet measurements, browser security, creating new testing techniques and tools. And I love exploring new attack ideas and side channels, on the web platform. So I'm delighted to be here on the ITSP Magazine podcast for OWASP, and hopefully share some useful insights and takeaways about request forgery attacks with everybody.
Yes, thrilled to have you on, Soheil. And it's stunning that request forgery attacks still exist. Right?
Yes.
Still. And I guess I shouldn't be surprised. I mean, new people join, and new code is written, and new vulnerabilities surface, even if they're the same method or model vulnerability from the past.
Absolutely.
Maybe let's start there. Actually, well, so this is. Let me say this first. So Thursday, the 27th of June, 3:30, you have a session that's called "In the Same Site We Trust: Navigating the Landscape of Client-Side Request Hijacking on the Web." And that's the session I wanted to dig into, and the topic I wanted to explore with you. So I think maybe a good place to start is kind of the history of. I want to put the C in front of it because it doesn't have to have a C, right? Or CS, the cross site, but request forgery attacks. Can you give us a kind of a history of those and how they've evolved?
Absolutely, yeah. So if you think about a web application, like they accept and process like plethora of user input, right? And these inputs come from like different parties, right? You go to a website, you fill a form, you submit the form, and there is a request from the same site to the backend of that site. But applications also accept requests via third-party endpoints. So, for example, payment gateways, social media integrations, all those other external services that are custom to each application and their business logic, right? So we have like first-party inputs and third-party inputs that are going to applications. And how do applications know which parties to trust, which requests are, let's say, trusted, which ones are not? Well, back in the days, we decided that, okay, let's use authentication and authorization to solve this problem. So we authenticate users' browsers via account credentials, username and passwords to say that, okay, this request is coming from this trusted party, from this specific user. Or we created like API keys, authorization tokens for like service-to-service like integrations. And it seemed back then that if we can just reject untrusted requests, the problem is solved. Well, it turned out 20 years ago not, because attackers can abuse trusted requests to cause unintended, let's say, changes. So imagine that you go to your banking site, you log in with your account, and then in another tab of your browser, you open a page that you don't know at the time is an attack page. And that page can send a request to your banking site. And if your banking site is vulnerable, this can easily lead to an illicit money transfer or any other, let's say, damage to you. And here the application is abusing the fact that your browser is trusted, is authenticated within that banking application, and it can send cross-site requests from the attacker's domain to the banking domain, so they are across two sites. And that's why back in the days, these class of attacks were called cross-site request forgery, or shortly CSRF. And hopefully nowadays we know how to defend against these attacks. There are a plethora of robust defenses to mitigate these attacks. So for example, anti-forgery tokens, you can just add one nonce or non-guessable token to the request, and the attacker cannot reliably reconstruct the request because they cannot guess the token. So the defense is actually very simple. But what happened was that as applications evolved, they shifted many of the functionalities to the client-side code. So we have like applications like Adobe Photoshop completely running in your browser. Many of these applications like Google Docs, lots of like client-side code. So this recent approach to client-side task offloading actually introduced like many more complex, let's say, vulnerabilities.
Can you describe one or two or whatever? Don't give anything away from the session, but
absolutely,
something to kind of paint a picture for us. That'd be great.
Yeah, absolutely. So cross-site scripting vulnerabilities. So now we have the problem of input validation again. So before the problem I described, the root cause was somehow called confused deputy, because the browser is tricked into sending an authenticated request, but it's not the user intention. So it was an unintended request, and that's called confused deputy flow. But now when we shift to client-side, when we shift the functionality to client-side, we run into essentially input validation flaws. So you take some input from the user in the client, and you don't validate it, but you somehow execute it, interpret it as code, and this leads to arbitrary code execution, essentially, which is worse than like somehow only cross-site request forgery before, because now attacker can execute any code, he can send requests. So now we have these requests that are created essentially in the client side and sent via the client-side JavaScript code. And in the same side we trust, that the talk that we're having is essentially how you can abuse or leverage these same-side requests to cause CSRF attacks that normally you should not be able to do because of like robust countermeasures that we have. But what if we abuse the same-side requests that are generated via the client-side code? So that's more or less, let's say, how the attack works and how it correlates to the early days of the CSRF.
Nice. I can't help but you have a picture behind you on your whiteboard. Is that JavaScript jumping the shark, or did I miss?
Yes, exactly. So this is actually a logo of the first version of the tool that we created to detect these attacks, called client-side CSRF. So now we have CSRF, and like back in the days, maybe 5 years ago, we came up with the term like client-side CSRF, particularly because of the vulnerability that affected Facebook. Let's say in 2018, they called it client-side CSRF, so we just adopted the term, from the post. And back then we focused only on like client-side CSRF, which is one variant. But recently we focused on like other types of requests that the browser can send. So browsers can send WebSocket connection. So you have this full duplex, like bidirectional channels. You have server-sent events, synchronous requests. So there are plethora of requests, that types of requests that the browser can send. Not just like asynchronous ones, like the one of client-side CSRF. And then we came up with the term request hijacking, meaning if you can control the requests the application is doing normally and somehow hijack it to your advantage to cause like damage.
Yeah, and of course, I was talking to Jim Manico the other day, and one of the things we touched on was it's not just manipulating code necessarily to do something. You can mess with the logic of the application. So, and then the data, right? So the data no longer has integrity in and out, and
exactly,
tons of fun stuff to consider there. I want to where was I going to go? I guess the question I had, I know there's been a lot of investment and development in the browser technologies.
Right.
And a lot of browsers using a lot of the same shared services. But what's the state of the browsers? Are they all kind of equally vulnerable to these types of attacks, or what's the story there?
Absolutely. So browsers, actually, this is so in this particular attack, like in the client-side variant, browser is doing nothing wrong. So it's mostly the flow of the application that is not validating input. In the traditional CSRF one, actually, browser was the party that was tricked into like making the request, and browsers since then created like defense-in-depth solutions for applications. Called same-site cookies, so which essentially restricts the cookies or these authentication tokens of, let's say, the website to the same request context. So they do not submit the cookies in cross-site request context by default, but strict those. And this will fix most classes of, let's say, CSRF attacks, including definitely the traditional ones. But this won't mitigate client-side CSRF because it's essentially abusing same-site requests, not cross-site requests. So those are legitimate requests that contain anti-CSRF tokens, random tokens that the applications have. They are same-site requests, so same-site cookies will not essentially impact them. And these are because of the application flaws. So application takes some input from, I don't know, URL, and they just use it, for instance, as the endpoint to which the asynchronous request is submitted. And this request can have, for instance, sensitive information, right? So if an attacker sends this request now to his own domain, they can hijack sensitive information included in the request. So the consequence is not anymore on the application, but it can also be on the user because the private data belongs to the user. So it's much more, the impact is much more, let's say, diverse and consequential, let's say, so to say. And actually the figure that you see behind me, I forgot to say it. So this is the logo of a vulnerability detection tool we created called JavaScript Analysis Framework. And this is what I'm going to talk about also at OWASP, not this version, but follow-up versions that is able to detect request hijacking vulnerabilities.
Nice one. So let's wrap, Soheil, with kind of an overview of the session, because my guess is engineers might make some assumptions around cross-site scripting and client side and not really understand the nuances of the same site stuff that you're going to be presenting. So talk to me about how the session is going to go, who should be there. I presume any developers at the conference would be interested in this, but how detailed and down and dirty are you going to get in the session?
So I think the talk will be appropriate for all audience levels, because I will start from like very basic like concepts that is easily understandable for everybody. But of course, it will be most beneficial to developers and security professionals who want to learn more about request hijacking, how to defend their applications against these class of attacks. Checking if they're vulnerable, learning how to use our automated vulnerability detection tool, hopefully integrated in their CI/CD pipelines and so on. But on the other hand, it will also be, I think, good for like people that are like totally beginners to learn about these like new class of attacks and get yourself like familiar with the evolving landscape of, let's say, request forgery attacks.
The evolving landscape. You sound like AI there. So
Right.
every prompt response to the evolving
Right.
landscape.
I mean, this is yes. I think that the request forgery, I think landscape is absolutely evolving, right? Because the complexity of applications are rising, particularly the client-side code. So we have all these types of like requests, and the client-side complexity is only evolving. So thereby the request forgery vulnerabilities in the client side.
Yeah. Tons of stuff to consider. You can start by attending the session in the same site we trust, navigating the landscape of client-side request hijacking on the web. That's Thursday, 27th, OWASP Global AppSec in Lisbon. Soheil, thanks for taking the time to share with me today. Congratulations on getting that spot to speak at OWASP in Lisbon. I look forward to meeting you in person.
Sure, yeah, of course. Thank you so much for having me, and thanks for this great and interesting chat. So see you in Lisbon, and hope to talk to lots of you in person in Lisbon.
Exactly. So anybody who's building web apps, go connect with Soheil, attend a session, and start a conversation, and hopefully I'll see you all there as well. And thanks everybody for listening and watching, if you're watching this, and please stay tuned. There's more coming to you on location, even if there's chats on the road like this one ahead of time from OWASP AppSec Global in Lisbon. Thanks everybody.
Thank you.
We hope you enjoyed this episode of Sean and Marco's On Location event coverage conversations. Please take a moment to give the show a good rating and leave a comment. Remember to share this podcast with your friends, family, and colleagues. Come back for more conversations and follow Sean Martin and Marco Ciappelli as they continue their journey toward redefining cybersecurity and society.